Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 6A assignment. First one we're going to take a look at here is number 1. Part A, find the length of the blue arc. So that's this length right here. One of our formulas in our book has arc length equals theta over 360. And remember, this is the angle times 2 pi r. So basically, just so you understand how this works, 2 pi r, that's the circumference of a circle, right? And then this is just going to take whatever fraction of a full circle it is. So in this case here, we're going to do the arc length equals 60 over 360 times 2 times pi times our radius here, which all of these radii here are all 5. So 2 times pi times 5. Okay? So what this means right here, 60 over 360 reduces down to 1/6. So that means that this blue piece here is 1/6 of a full circle. So it's 1/6 times 2 times pi times 5. Okay, so we can just put that on our calculator. So we'll do 1 divided by 6 times 2 times, you want to find the pi button on your calculator. Mine's right there. 2 times pi times 5, and that gives us that arc length is 5.24 we'll go with. So the arc length in this case is 5.24 centimeters. Okay? Okay, moving on to number 2, find the perimeter. So remember, the perimeter is this arc here plus this straight line across here. So we got 3.4 and 3.4 here. So those two plus this semicircle, right? So we can use this little arc length formula. So the arc length is going to equal the angle measure, which is 180 degrees over 360, which is just half of a circle, hence the 1/2 part, times 2 times pi times our radius is 3.4. So times 2 times pi times 3.4. So this 2 and 1/2 reduced down to 1, so it's just 3.4 times pi for the semicircle part. 3.4 times pi, right? And we get let's go with 10.7. So this here is 10.7 centimeters. So our total perimeter is going to be 10.7 plus 3.4 plus 3.4. So we got our, let's do 10.7 plus 3.4 times 2, or you could do 3.4 times 3.4 plus 3.4, so 17.5. And that is going to be centimeters is our perimeter for that one. Okay, we can move on to E here. So the perimeter, again, is going to be the total length. So think of all the dark line here, all the black line here is all like fencing or something like that. How much fencing do you have to use? So that's 6.2 there. This is 6.2 here. So our perimeter is going to equal 2 6.2s, right? This one and this one, plus our whatever this arc length is here, plus the arc length AL. So our arc length there is going to be 260 over 360. Arc length equals times 2, oops, shouldn't put that so far up there, times 2 times pi times the radius, which we figured out is 6.2. Okay, so we can simply just put that into our calculator and away we go. So 260 divided by 360, just to give you an idea, 72, that's 72% of a full circle. Oops. Let me move that back up there. Okay. Sorry, let's see. So that gives us our 72 times 2 times pi times 6.2. And that gives us 28.1 we'll go with. So this is 28.1 for our arc length. So push plus 28.1 here. And we end up getting 2 times 6.2 plus 28.1. And that gives us 40.5. Okay? Equals 40.5, and this is meters, so the perimeter 40.5, and this is also perimeter over there as well. All right, moving on to number 5 here. Sorry, find the area of this here. So what we want to do, arc length isn't going to really help us much, but really it's got the same idea. Is basically we're going to figure out, we've got, like say, let's do this. Let's do, area of a circle. Circle is circle with a dot in the middle. Area of a circle is going to equal pi r squared, right? So this circle here is just going to be half of that circle because it is, so the area of a sector is going to equal, we'll use this same idea here of theta over 360 times pi r squared. Okay, so this is 180. So we do 180 over 360, which gives us a half, times pi times our radius, which is 8.2 squared, right? So that's going to be the area of the sector. So we can plug that in and away we go. So we've got 0.5 times pi times 8.2 squared. All right. Gives us 105.6, and let's see, I'm good with 105.6 equals 105.6 millimeters squared, since we're talking about area. So the area of that piece there, 105.6 millimeters squared. Okay, and then for E, I'm going to do the same thing. So our area of our sector is going to equal our angle 215 over 360 times pi times our radius squared, and our radius in this case is 8. Okay, so we can put that into our calculator and see what we get. So 215 divided by 360 tells us that this is like about 60% of a full circle, times pi times 8 squared. Right? And we get 120.1, or just 120, we can go with that. 120 meters squared would be the area for that one. Okay? All right, last one to take a look at, number 8. A running track consists of 2 straight segments, these here, joined by semicircular ends here. Total perimeter of the track is 1,600 meters. Determine the diameter of the semicircular ends. So basically they're saying, what is this length here? So how about this? We know the total circumference of this entire track is 1,600, right? So that's going to be these 2 lengths here plus the 2 semicircles. So basically, circumference is going to equal the 2 500-meter lengths plus the 2 semicircles. But if you think about it, if you take those 2 semicircles, add them together, then that's also going to be the circumference. So let's just do, so plus the circumference. So the I'm going to do this. I'm going to put 1600 in here. So 1600 has to equal 2 times 500 is 1,000. Wow, it's a little glitchy there. Sorry. 1,000 plus the circumference. So subtract 1,000 from both sides. And we know that the circumference of this entire circle, so again, we've got the two sides here, and if we take these two end caps off, put them together, we've got this circle. So we have these two sections here, plus if you clip those two together, you get a full circle there. So the circumference of this circle we know has to be 600 meters. Okay, so they want to know what the diameter is. So diameter equals, let's see, pi. Actually, let's take a different angle at this. Circumference equals, it's either 2 times pi times the radius, or circumference just equals the diameter times pi. Since we know the circumference is 600, plug that in there. 600 equals diameter times pi. So divide both sides by pi, and that will tell us what our diameter has to be. So 600 divided by pi gives us that diameter is going to have to be about 191 meters. Okay, so that takes care of A. And then for part B, Jason takes 4 minutes, 25 seconds to complete a single lap of the track. Calculate Jason's average speed in meters. MS in the negative first means meters per second. Okay? So 4 minutes, 25 seconds. So what we need to do is for part B, we got to figure out how many meters and how many seconds. So first thing, or it doesn't matter which one you do first, but 4 minutes, 25 seconds. We got to turn these minutes into seconds, right? So times that by 60 to give us 240 seconds plus 25 seconds is going to give us 265 seconds. So 265 is going to go on the bottom. And then the total, let's see, to complete a single lap of the track. Well, we know already that the total perimeter of the track is 1,600 meters. So we just do 1,600 divided by 265, and that should give us his speed in meters per second, right? So 1,600 divided by 265 gives us about 6 meters per second. Okay? You're going to write that 6.04 meters per second. Pretty much just right about 6 meters per second. Okay, that's all we have for the 6A problems. If you have any questions on this or anything else, please feel free to ask. Thanks.